Unitree Robotics developed an innovative platform for full-body teleoperation and embodied avatars and tested it on their humanoid robot G1, turning the machine into a kind of remote human body. This embodied avatar system allows an operator to control the robot's movements in real time, almost one-to-one replicating human gestures, steps, and actions. In the demonstration, the operator in a special suit and VR headset transmits hand, torso, and leg movements to the robot. The robot synchronously mimics the poses, maintains balance, and manipulates objects. This is not just remote control. The system integrates full-body tracking, motion sensors, and stabilization algorithms to compensate for signal delays and preserve stability during rapid movements. If the operator steps forward or swings an arm, the robot interprets the trajectory and safely reproduces it considering its own center of gravity. In honor of the Chinese New Year, Unitree Robotics presented a large-scale and truly futuristic humanoid robot performance that became one of the most talked-about technological moments of the festive Gala show, with dozens of robots taking the stage and synchronously performing a cyber kung fu routine, showcasing not just dance moves, but complex combat combinations, rapid turns, staff work, and extremely precise group coordination. The main stars were the G1 series humanoids, compact yet highly agile robots, capable of executing dynamic movements at high speed while maintaining balance even during sharp maneuvers, with motion that appeared remarkably fluid as sharp strikes transitioned into smooth movements, and group synchronization created the impression of a rehearsed troupe rather than machines, while some scenes were styled after classical Chinese legends, with robots appearing in looks inspired by traditional cultural characters, including references to the Monkey King. In front of you is Quanta 2, a next-generation humanoid robot from X Square Robot, created as a universal service assistant for real-world environments, ranging from hotels and business centers to residential complexes. Unlike classic walking androids, Quanta 2 is built on a stable-wheeled platform, making it faster and more stable when moving through corridors and indoor spaces. The robot's height is comparable to that of a human, approximately 1.6 to 1.7 meters, allowing it to operate within standard infrastructure, such as doors, buttons, and reception counters. The key feature of Quanta 2 is its advanced manipulators. The robot has about 62 degrees of freedom, including roughly 20 degrees of freedom in its hands. The fingers move independently, enabling precise actions such as picking up small objects, carrying containers, holding boxes, pressing buttons, opening doors, and interacting with everyday items. In demonstrations, it confidently transports a basket, adjusts arm positioning while in motion, and maintains balance even when the load changes. In front of you is an advanced humanoid robot called U2 from Navi AI, which is actively learning and already demonstrating real-world application scenarios. It is an upper-body platform focused on precise manipulation and work in industrial and service environments. One of the key demonstrations is screw fastening using visual servoing. The robot detects holes with cameras, aligns the tool, and performs precise fastening with high repeatability, a level required for assembly lines. In addition to autonomous tasks, Navi AI is developing teleoperation, where an operator wearing a VR headset can control the robot in real time, transmitting arm and torso movements, allowing U2 to sort objects, work with tools, and even cook by replicating human motor skills. The company also demonstrates applications in retail, where the robot recognizes products, adaptively grasps objects of different shapes, and interacts with the surrounding environment. A video is gaining popularity online, showing a person putting on a jacket and seemingly disappearing into the surrounding landscape. Surprisingly, the creators did not use editing or cinematic effects. The clothing actually exists and vanishes into the environment thanks to a special fabric structure. The model is called the Hillside invisibility jacket and has already caused a stir on social media, collecting thousands of comments. People debate how this is possible and whether it is true that someone wearing this extraordinary bomber becomes invisible. The secret lies in retroreflective technology. Tiny glass beads no larger than a human hair are embedded in the fabric. Unlike ordinary surfaces, they do not scatter light but return it to its source. If light from a flashlight is shown on such an item and filmed from the same angle, for example with a smartphone with its light on, the jacket reflects the entire beam directly into the camera lens. The result appears as if the person has dissolved, leaving only a distorted background visible. The technology was developed by Hillside. It is their patented design based on layers with microscopic reflective elements. The beads are coated with a special compound that makes the reflection highly directional. This creates an optical illusion where the observer sees what is behind the person rather than the fabric itself. The closer the viewing angle is to the light source, the stronger the erasing effect. Recently, Deep Robotics released several videos showcasing their advanced Robo-Dog M20. In the first demonstration, the robot actively prepared for winter testing inspired by the atmosphere of the Winter Olympics. M20 moved confidently across an ice arena, performed maneuvers on slippery surfaces, and demonstrated stability during sharp turns. Engineers tested its balance, wheel-leg traction, and ability to adapt to a dynamic environment where any wrong move could cause it to lose stability. In the second demonstration, M20 was subjected to extreme cold conditions. Tests took place in the snowy fields of Hulunbuir at temperatures down to -30 degrees Celsius. The robot moved through deep snow, overcame uneven terrain, wind, and icy patches, confirming the stability of its electronics and actuators in harsh weather. Testing showed that the control system and battery module maintain functionality even in severe frost, and stabilization algorithms allow it to keep balance on loose and slippery surfaces. Toyota developers have presented a new revolutionary project called WalkMe, an innovative next-generation wheelchair that does not just roll on a surface, but literally walks on robotic legs. Unlike traditional wheelchairs, WalkMe is equipped with 4 independent robotic supports that allow it to overcome steps, uneven terrain, curbs, and other obstacles in urban environments. Instead of wheels, it uses walking modules with advanced stabilization that automatically analyzes the surface and adjusts movements in real time. One of the key features is the ability to climb stairs without external assistance. Built-in sensors and balance algorithms calculate the center of gravity, adjust the body position, and ensure smooth, safe movement up and down. Additionally, the chair can raise the user to the level of a car seat, simplifying getting in and out. Menty Robotics released a video showing 2 V3 humanoid robots autonomously performing a warehouse logistics process. They move along shelving, recognize boxes of varying heights, carefully pick them up with manipulators, and place them in the correct storage zones without direct operator control. In the demonstration, the robots operate in a real warehouse environment, among metal structures, shelves, and containers. Their computer vision system analyzes the space, determines object dimensions, and adjusts movements in real time. Thanks to integrated AI, depth sensors, and trajectory planning algorithms, the machines can adapt to changes in box placement and obstacles while maintaining stability and precision in handling. This is not science fiction or an anime scene, but the reality of modern Japan, where humanoid robots are gradually leaving laboratories and becoming part of everyday life. For decades, Japan has invested in robotics not simply as a technology, but as a strategy for societal survival. An aging population, labor shortages, and loneliness in megacities have created a unique environment in which robots have ceased to be exotic and have become tools of social transformation. Today, Japanese humanoid robots are no longer primitive automatons with memorized phrases. They are complex cyber-physical systems combining high-precision mechanics, advanced sensing, computer vision, voice models, and learning neural networks. They recognize emotions through facial expressions and intonation, adapt speech to the interlocutor, analyze conversational context, and adjust behavior to social situations. In essence, we are seeing the first early forms of social AI, machines that learn not only to be useful, but to be understandable and emotionally acceptable to humans. The Japanese school of robotics has always emphasized not only functionality, but also appearance. Unlike the utilitarian Western approach, where a robot is primarily a tool, in Japan it is often designed as a character, with facial expressions, fluid movement, micro-expressions, simulated breathing, and gaze. Engineers and designers work together with psychologists and neurobiologists to create a sense of personal presence, which is critical because humans subconsciously trust those who behave in human-like ways, making eye contact, pausing in speech, and responding to emotions. A key role here is played by next-generation artificial intelligence. Modern models process not only text and voice, but also bodily signals, posture, gestures, micro-movements of the head, and reaction speed. The robot analyzes human behavior in real time and adjusts its own movements so as not to appear mechanical. That is why new humanoids move smoothly, make small mistakes, slow down when they appear to think, and create the illusion of an inner life. This is no longer simple imitation, but trainable behavior formed on massive datasets of how real people act. In Japan, robots are increasingly used in elderly care, hotels, reception desks, shopping malls, educational projects, and even therapy for people experiencing social isolation. In a country where loneliness has become a widespread social phenomenon, humanoid robots serve not only as assistants, but also as emotional interfaces between humans and the digital world. They do not directly replace people, but they lower the barrier to social contact. It is easier to start a conversation with a robot than with a stranger. However, behind this technological breakthrough lies a serious philosophical question. Where is the boundary between machine and human? The more human-like robots become, the more the sense of artificiality blurs. Already today, in demonstration halls and exhibitions, people sometimes mistake advanced humanoids for live actors or cosplayers. In the coming years, the combination of realistic appearance, synthetic skin, micro-expressions, natural speech, and autonomous behavior will make it almost impossible to distinguish a robot from a human without prior knowledge, especially during brief interactions. This opens enormous opportunities as well as new risks. On one hand, humanoid robots can take on heavy physical labor, customer service, dangerous tasks, and part of the social burden. On the other, questions of trust, ethics, and psychological dependency arise. If a robot becomes human-like enough to evoke emotional attachment, society will need to regulate these relationships to prevent the replacement of genuine human connections with technological imitation. In effect, Japan today is a testing ground for the future, where a model of coexistence between humans and humanoid machines is being developed. A new type of AI is emerging here, not merely computational, but embodied in a body, in movement, in gesture, and in gaze. And it is precisely this embodied AI that may become the next stage of technological evolution, when machines stop being a background to our lives and become active participants in it. The question now is not whether robots indistinguishable from humans will appear, but whether we are ready for a world where the boundary between human and machine becomes increasingly blurred, and where technology begins to speak to us in the language of emotions, habits, and human behavior. Meanwhile, in the world of robots, the Chinese company UB Tech Robotics became the first in the world to demonstrate a humanoid robot capable of replacing its own battery without any human intervention. UB Tech Robotics released a video showing Walker S2 approaching a dedicated battery station, carefully removing the depleted battery and placing it on a rack, then inserting a fully charged replacement into itself. The process takes about 3 minutes. Walker S2 is equipped with a dual battery power balancing system and uses standardized battery modules. If the main battery fails, the robot automatically switches to the backup, ensuring uninterrupted completion of important tasks. Autonomous battery replacement reduces downtime, lowers maintenance costs, and increases overall efficiency of production processes. Additionally, Walker S2 can dynamically choose between replacing the battery or charging it depending on the priorities of current tasks, providing adaptive energy management. Lately, More and more rumors suggest that Apple could unveil its first smart glasses, Apple Glasses, this year. A new product expected to take interaction with technology to a completely new level and become an important part of the Apple ecosystem. According to recent insider reports, Apple plans to announce the smart glasses in 2026, with a possible early preview to give developers time to prepare apps and services before sales launch. According to widespread rumors, the first Apple glasses will differ from the expected future AR device. They likely will not have a full display in the lenses like virtual or augmented reality headsets, but will include cameras, speakers, microphones, and intelligent functions capable of analyzing the surrounding environment and interacting with the user. These glasses will be closely linked to the iPhone, similar to how Apple Watch and AirPods work today, acting as an extension of the smartphone's capabilities and providing new ways to interact without constantly looking at the screen. Before you is a transport robot of the future that may soon replace conventional SUVs and ATs, Kawasaki Coro, a futuristic robotic horse created by Kawasaki Heavy Industries as a revolutionary way to move across rough and hard-to-reach terrain. Coro is not just another robot but a four-legged all-terrain mobile robot whose design is inspired by nature. The stability and agility characteristic of wolves and large cats are embodied in mechanical form. Instead of wheels, Coro has 4 robotic legs, each equipped with anti-slip rubber hooves that provide reliable traction on surfaces, ranging from rocks and mud to forest trails and slopes. The robot runs on hydrogen energy. A compact 150 cubic centimeters hydrogen engine generates electricity that powers electric motors in each leg. Control of Coro is as intuitive as possible. Instead of traditional levers and joysticks, the rider controls movement by shifting their own body weight, similar to riding a horse. In China, the humanoid robot Kepler K2 is already deployed on real production lines and is gradually working alongside humans in industrial settings. This is not a show prototype, but a fully operational platform designed for heavy and potentially hazardous tasks. Kepler K2 is a full-size industrial humanoid about 170 centimeters tall and weighing roughly 65 kilograms. Its body is made of durable composite materials and metal, built to operate in factory conditions. The robot is equipped with powerful servos, enabling it to lift and hold significant loads, as well as perform precise operations, including welding and manipulating large components. One of K2's key features is collaborative high-altitude welding. The robot works together with humans in high-risk zones. Thanks to computer vision and depth sensors, it accurately positions the welding tool, maintains stable force, and ensures consistent welds, reducing worker strain and improving safety in the facility. Moving on to the United States, we see the latest development in humanoid robotics. The Sprout platform from the New York-based company Fauna Robotics. This is not just a demonstration robot, but a full-fledged experimental system for developing so-called embodied artificial intelligence, AI that learns to interact with the real physical world through a body, movement, and sensors. Unlike classic industrial robots, Sprout is designed to operate in human environments, offices, laboratories, and everyday spaces, where safety, smooth motion, and adaptation to unpredictable situations are critical. Platforms like this form the foundation of future humanoid systems that will be able to learn in real conditions, absorb skills from humans, and gradually become universal assistants. Sprout shows how the physical embodiment of AI accelerates the development of robotics and brings closer the moment when humanoid robots cease to be an experiment and become part of everyday reality. The future in which robots serve people in everyday life has already arrived. 1X Technologies has unveiled its home humanoid robot Neo, a compact, safe platform designed to assist with household tasks. Neo is built specifically for home use and, unlike industrial humanoids, features a soft outer shell and lightweight construction, making it safe to interact with people including children and the elderly. The robot moves naturally and quietly, adapting to the layout of an apartment or house. Neo's main role is household assistance. It can carry objects, hand items to users, help with cleaning, fold clothes, maintain order, and interact with everyday household objects. It is equipped with manipulators capable of gently grasping items of various shapes, while built-in sensors and a computer vision system allow it to navigate indoor spaces and avoid collisions. Neo is also integrated with an intelligent control system that enables it to understand voice commands and adapt to the owner's habits. Engineers from Suzuki have introduced a new class of personal mobility transport capable of overcoming not only urban roads, but also stairs, curbs, and complex terrain, called MQBA. It is an experimental development that combines features of an electric scooter and a walking robot. The abbreviation MQBA stands for Modular Quad-Based Architecture, and it is precisely this four-support modular design that makes the concept unique. The device's main feature is 4 independent legs, each ending with a wheel. On flat surfaces, MQBA moves like a conventional electric vehicle, providing stability and comfort. However, when encountering an obstacle such as stairs, the walking mode is activated. Each leg lifts and steps upward in sequence, allowing the machine to literally climb. According to preliminary data, the device can reach speeds of up to approximately 32 kilometers per hour and travel up to 80 kilometers on a single battery charge, making it competitive with other personal electric vehicles. What we see here is also a vivid example of how artificial intelligence is moving beyond factories and laboratories to become part of culture and public performance. On stage are robotic performers synchronously beating traditional Chinese drums. Behind this impressive image lies far more serious technology: computer vision systems, machine learning, and precision motor control that allow robots to move in sync, sense rhythm, and adapt to the stage in real time. Every movement of these machines is the result of complex coordination, balance, and prediction algorithms. The robots do not merely repeat a pre-recorded dance. They constantly adjust arm position, striking force and tempo, adapting to the music and neighboring performers. In effect, we are witnessing the first steps toward autonomous digital artists capable of participating in shows, events, and large-scale productions. Yet beneath the spectacle lies a deeper meaning. The same motion control technologies used on stage will tomorrow be applied in industry, logistics, and service robotics. This is a clear demonstration of how AI is learning to operate in complex, dynamic environments, among people, in motion, and beyond the sterile conditions of laboratories. Meanwhile, engineers from the HiTR research project presented an intelligent control system tested on the production humanoid Unitary Robotics G1. They effectively taught the humanoid robot to play table tennis in real time, including ball trajectory prediction, impact point calculation, and full body coordination. In the demonstration, G1 serves as the hardware platform, while the core innovation lies in the algorithmic architecture for table tennis play. The researchers implemented a hierarchical control system. The high-level layer predicts the ball's flight and plans strike strategy, while the low-level layer controls torso, leg, and racket arm motion using reinforcement learning. Since ball speeds in table tennis can exceed 5 meters per second, the robot must perceive, analyze, and act within fractions of a second. The system computes the strike position, swing speed, and precise contact timing, then generates coordinated whole-body movements involving not just the arm, but also the torso and legs to maintain balance. Tesla is entering a new and far more dangerous stage in the development of its humanoid robot Optimus. According to sources close to the company, Tesla is currently working on the most serious update in the project's history, one that aims to transform Optimus from an advanced machine into a humanoid robot that is nearly indistinguishable from a human. The key goal of this phase is next-generation artificial skin, facial expressions, natural body movement, and a radically improved AI that allows the robot not just to execute commands but to behave naturally in human environments. Insiders claim that Tesla is testing multi-layer synthetic skin, in which the outer layer is responsible for appearance and texture, the middle layer for elasticity and a living tissue effect, and the inner layer for integration with pressure, temperature, and micro-strain sensors, meaning future versions of Optimus will be able to feel touch, regulate contact force, and visually appear almost human, fundamentally changing its role from a factory assistant into a potential social agent capable of operating around people without causing discomfort. Tesla is placing particular emphasis on pairing the robot with next-generation AI, giving Optimus upgraded perception neural networks that improve recognition of faces, emotions, micro-gestures, and even changes in voice intonation, an internal shift the company refers to as human-oriented AI, where the robot begins to understand situational context rather than simply responding to commands and can adapt behavior based on human mood, environment, and potential risks. According to sources, Elon Musk is personally overseeing this phase of the project, viewing Optimus not as a side experiment, but as a strategic asset for years ahead, with the robot project now competing in priority with autopilot and battery technologies inside Tesla, and Musk reportedly pushing for faster development due to growing competition from China, where multiple companies are bringing humanoid robots to market for industrial and service use, with Tesla aiming to outperform rivals not through scale, but through technological superiority and realism. The most intriguing aspect is timing, as insiders suggest Tesla plans to unveil the updated Optimus in the near future, not as a distant concept, but as a next-generation demonstration prototype, featuring realistic skin, improved facial expressions, and behavior closely resembling that of a human, sending a clear signal that Tesla is entering the humanoid robot race, not for experimentation, but for leadership. If this update is realized as planned, Optimus could become the most advanced humanoid robot on the planet in terms of AI, mechanics, and visual realism, placing Tesla in direct competition with Chinese robotics giants over the future of human-like machines. But behind the impressive demonstrations lies a deeper strategy, as Tesla understands that victory will go not to the first company to show a humanoid on stage, but to the one that can make it mass-produced and economically viable, which is why alongside realistic skin and human-like AI development, the company is already retooling production lines for serial manufacturing of next-generation Optimus, designing the robot to be assembled on the same automated infrastructure as Tesla's electric vehicles, with maximum part unification, fast module replacement, and minimal cost at scale. Internal estimates suggest that once mass production begins, the cost of a single Optimus could drop sharply, marking a turning point for the market, because once humanoid robots become accessible not only to corporations, but also to mid-sized businesses, a true adoption wave will begin across warehouses, hotels, retail chains, and service companies, pushing the race with China to a new level where the competition is no longer about prototypes or demo shows, but about who can fill the world faster with human-like machines. Recently, Russian developers showcased their new humanoid robot named Adall, but something went wrong during the demonstration, and on stage in Moscow, the machine unexpectedly lost balance and fell directly in front of the audience. The presentation was designed as a public debut in which the robot was supposed to emerge from backstage, walk to center stage, greet the audience, and demonstrate basic autonomous locomotion, with the first steps appearing confident as Adall moved with a heavy gait, waved to the crowd, and seemed to maintain balance. But at a certain moment, the stabilization system failed. The robot pitched forward sharply and could not compensate for the shift in its center of gravity. Company staff quickly rushed onto the stage to lift the device and prevent damage, and an attempt to cover the incident with a curtain only amplified the drama, with the video rapidly spreading across social media. In front of you is the new four-legged robot Apollo, an industrial quadruped developed by MirrorMe Technology and Kayerda as a universal platform for operating in real-field conditions, designed for use outside laboratories on construction sites, in industrial environments, and across rough terrain, featuring a modular locomotion architecture that allows it to adapt to different surface types, overcome obstacles up to 20 centimeters high, confidently traverse uneven ground, and maintain stability during sharp directional changes. while an intelligent perception system with cameras and sensors enables environmental mapping, obstacle detection, and autonomous route planning. And the platform supports additional payloads for inspection, infrastructure monitoring, and technical diagnostics. Developers from the OpenArm project created an innovative 7-degree of freedom humanoid robotic arm called OpenArm 01, designed for research in physical AI and operation in environments with active physical contact. OpenArm 01 is a fully functional manipulator built with kinematics close to that of a human arm, providing high mobility, natural motion trajectories, and the ability to perform complex manipulation tasks, such as grasping objects of various shapes, precise positioning, tool use, and interaction in contact-rich environments. Thanks to its 7 degrees of freedom, OpenArm 01 can execute movements similar to a human arm, including bending, rotation, extension, and complex combined trajectories, allowing the manipulator to precisely adapt to an object's shape and adjust its position during grasping. Here is one of the most ambitious attempts to create a brain for next-generation robots. It is about a startup valued at billions of dollars that is developing so-called physical intelligence, artificial intelligence capable not just of recognizing objects, but of understanding the physics of the real world and acting within it in real time. Unlike traditional robots that operate according to pre-programmed scenarios, this AI makes decisions on the fly: how to grasp a cup, how to pour liquid, how to adjust movement to an unstable object. The robot does not replay a memorized animation. It calculates trajectories at the very moment of interaction, taking into account weight, shape, inertia, and resistance. The key goal of such developments is to create a universal motion intelligence engine for robots that can be transferred from one platform to another, from kitchen manipulators to industrial humanoids in factories. If systems like this reach the mass market, we will for the first time see robots that do not simply execute commands, but genuinely understand the physical reality around them and begin to function almost like living assistants. Here is another ambitious Kawasaki project in advanced mobile robotics: the robotic goat Kawasaki Beex, designed to transport cargo and even people. It was first presented to the public at the International Robot Exhibition in Tokyo, where it attracted attention for its unusual combination of mechanical biomimicry and real practical purpose. A unique feature of Beex is its hybrid mobility system. In addition to walking on legs, small wheels are built into its knees and can extend outward. This allows the robot to switch to wheeled mode when on flat surfaces such as asphalt or indoors. This combination of walking and driving makes Beex versatile in various conditions. The project also provides for the possibility of transporting people. A comfortable seat and steering controls are installed on Beex's back, making it something like a living all-terrain vehicle that can be ridden. In addition, Beex is capable of carrying loads of up to 100 kilograms, making it potentially useful for logistics, agriculture, construction, or inspection work at large facilities. Robot dogs have reached a new level as Pudu Robotics introduced the Pudu D5 series, an industrial-grade autonomous quadruped robot combining strength, maneuverability, and elements of acrobatics. Demonstrations show that the robot does more than walk. It can perform dynamic movements, accelerate rapidly, pivot in place, and maintain balance during sharp trajectory changes. With powerful actuators and an advanced stabilization system, D5 confidently moves across rough terrain such as mud, rocks, forest trails, and uneven ground, adapting its gait in real time. Its dynamic capabilities are particularly notable, as the platform is designed for complex maneuvers and acrobatic elements, including sharp jumps and flips, demonstrating a high level of body control and joint coordination, which makes it stable even in extreme conditions. In addition to mobility, Pudu D5 can carry loads and operate as an autonomous mobile delivery platform. Tesla is radically changing its development vector. According to sources within the industry, the company led by Elon Musk no longer views robots as a side experiment to its automotive business. On the contrary, Tesla is fully committing to robotics and betting on an entire family of autonomous machines. Optimus is becoming not a single product, but the foundation of a new Tesla robot ecosystem, and the company is already preparing to launch a second line, Optimus Robo-Dogs, which are expected to complement humanoids and cover additional use cases. Why Robo-Dogs specifically? Because this is the most practical and rapidly scalable robot format for the real world. Quadruped platforms are more stable, easier to control, and better suited for stairs, uneven terrain, and outdoor work. For Tesla, this is the ideal entry point into mass robotization. While Optimus humanoids are being prepared for production in the thousands for factories and warehouses, Robo-Dogs can occupy niches in security, territory patrol, infrastructure inspection, hazardous zone operations, and logistics at complex sites. According to insiders, the new robot will visually resemble Optimus, a recognizable helmet, the signature black and white palette, an illuminated Tesla logo, and the company's overall design language. This is not just aesthetics. Tesla aims to create a unified robot brand so that humanoids and robo-dogs are perceived as parts of a single ecosystem. Inside the robo-dogs will operate built-in AI based on the same neural networks used in Optimus and Tesla's autopilot. This implies one brain for different bodies, a humanoid, a quadruped robot, and, in the future, other forms will be able to learn within one system and share skills. Strategically, Tesla is openly targeting competition with China. Chinese companies are already mass deploying quadruped robots for industry, security, and specialized tasks. Elon Musk, according to sources, believes Tesla must not merely catch up but technologically surpass Chinese manufacturers through stronger AI, better autonomy, and deep integration with the company's ecosystem. If Chinese robo-dogs are primarily hardware-focused, Tesla is betting on AI with a body, a robot that understands context, adapts to its environment, and learns from real-world operational scenarios. It is also important how this fits into Tesla's manufacturing strategy. The company is already preparing for large-scale production of thousands of Optimus humanoids for its own factories and partners. Assembly lines, component logistics, and supply chains are being restructured for these volumes. Robo-Dogs appear to be a logical expansion of the lineup. Many modules will be unified: AI processors, batteries, actuators, vision, and communication sensors. This will allow Tesla to rapidly scale production of different types of robots without proportional cost growth. Essentially, the company is building robot factories based on the same principles it once used to scale electric vehicle production. While Tesla has not disclosed the exact specifications of the new robot, insiders speak of a high degree of autonomy, advanced computer vision, the ability to navigate complex environments, and basic object manipulation via modular attachments. Optimus robo-dogs will be able to operate alongside humanoid robots. Quadrupeds will enter hazardous zones first, conduct reconnaissance, deliver tools, and ensure security, while humanoids will perform precise manipulations and complex tasks. According to sources, Elon Musk plans to present this lineup in the first half of 2026. This will not simply be a concept reveal, but a demonstration of Tesla's strategy as a next-generation robotics company. In effect, Tesla is preparing to move beyond the automotive industry and become one of the largest players in the autonomous machine market, humanoid, and beyond. And if this plan succeeds, in the coming years, we will see not just Tesla robots on presentation stages, but real robots in factories, on streets, at infrastructure sites, and in business operations. At that point, it will become clear that Tesla has definitively shifted from producing machines for people to producing machines that work instead of people. Familiar pavilions and service points are transforming into autonomous robotic spaces of a new generation as AI Robotics introduce SmartCube, a modular intelligent service station that integrates robots, automation, and urban infrastructure in a compact format, where SmartCube is not just a kiosk or a single robot, but a fully autonomous service environment housing the AlphaBot 2 robot that serves customers without human involvement and, depending on configuration, can prepare coffee, ice cream, beverages, or other products adapted to location-specific demand, with the key advantage being modularity that allows rapid deployment in public spaces, such as parks, shopping centers, and business districts, significantly faster than traditional construction, while all operations are managed remotely through a digital monitoring system. Developers from the Istituto Italiano di Tecnologia have also impressed the world with their four-legged robot HighQ Reel, capable not only of confidently moving across rough terrain, but also of demonstrating remarkable strength. For example, towing a real passenger aircraft weighing about 3.3 tons. HighQ Reel is a hydraulic quadruped robotic platform developed to create reliable robotic assistance for complex tasks such as rescue operations, agriculture, or hazardous area inspections. It is a massive robot measuring about 133 centimeters in length and 90 centimeters in height, weighing approximately 130 kilograms, making it significantly larger and more powerful than many other quadruped robotic systems. Special rubber supports provide maximum surface grip, while onboard computers manage balance and force distribution in real time. The robot is powered by a battery system and can operate autonomously for several hours. Meet the new humanoid robot DR02 from Deep Robotics, one of the most ambitious projects in the field of industrial human-like machines. The robot stands approximately 175 centimeters tall and weighs around 65 kilograms. DR02 can move at speeds of up to 4 meters per second, confidently maintains balance during sharp turns, and can climb slopes of up to 20 degrees. It is also designed for load carrying, with a total payload capacity of up to 20 kilograms, while each arm can lift about 10 kilograms. In demonstrations, DR02 showed more than just walking on flat surfaces. It moved confidently across rough terrain, passed through water, maintained stability under pushes, and performed smooth dynamic movements. In separate videos, it demonstrated elements of Tai Chi, highlighting precise joint control and torso balance, and also performed energetic dance movements combining strength and flexibility. A new humanoid robot called Tien Kong 3.0 has been introduced, which may represent a breakthrough in tactile interaction and dynamic whole-body control. Tien Kong 3.0 has become the first full-size humanoid robot capable of dynamically controlling full-body movement while simultaneously interacting through touch, meaning it responds to physical contact, adapts its posture, and adjusts movement trajectories in real time. Rather than simply executing pre-programmed actions, it accounts for external forces and changes its behavior on the fly. Thanks to an advanced sensor system and sophisticated balance control, Tien Kong 3.0 can maintain stability during contact with objects or people, perform complex coordinated movements of the torso and limbs, and operate in environments requiring rapid reaction. The developers have also focused on an open platform ecosystem, aimed at solving compatibility challenges humanoid robots face during industrial deployment, from software integration to connecting external modules and equipment. Deep Robotics showcased the mass production of its quadruped robot dogs, demonstrating not laboratory prototypes, but a fully operational industrial assembly and shipping line for serial models. The footage shows dozens of identical robots lined up, confirming that this is not small batch demonstration hardware, but true conveyor-based manufacturing. The company states that it has established a complete production system for its entire quadruped lineup, from inspection units to more advanced industrial versions. Deep Robotics' four-legged robots are designed to operate in complex environments. They can move across rough terrain, stairs, industrial facilities, and uneven surfaces. Their design includes reinforced joint actuators that provide stability and precise limb positioning even during dynamic motion. The robots are equipped with computer vision systems, LiDAR, and balance sensors, allowing them to autonomously navigate space, avoid obstacles, and perform inspection tasks. Urban Naps introduced its next-generation solution called Wellness Pod, an innovative concept that rethinks short rest and energy recovery in the modern megacity, with smart rest capsules creating a comfortable, technological, and relaxing environment where people can take a 15 to 30 minutes power nap to quickly recharge and boost productivity during a busy day, suitable for use in corporate offices, airports, co-working spaces, shopping centers, and other public or work environments where rapid energy recovery directly impacts focus, efficiency, and overall well-being, featuring an ergonomic zero-gravity chair that helps the body assume a deeply relaxed position, reduces spinal load, and relieves muscle tension, along with a fresh air ventilation system that maintains comfort even in full isolation, while built-in meditative soundscapes and soft adjustable lighting help users enter a restorative state faster and regain mental clarity. DJI announced the launch of its new flagship heavy-lift cargo drone, Fly Cart 100, on the Chinese market. Designed for industrial and critical logistics, the FC-100 is built to transport payloads up to 80 kilograms and operate in high-altitude and high-risk conditions far beyond the typical use of consumer drones. The drone has a maximum takeoff weight of 149.9 kilograms and can cover up to 6 kilometers on a single battery at full load. With 2 batteries, it can lift up to 65 kilograms of payload and reach distances of up to 12 kilometers. Without cargo, its range extends to 26 kilometers. The DJI FC-100 uses a 41 ampere-hour battery with support for fast swapping and ultra-fast charging, fully recharging in just 9 minutes with an optional 12,000 watts wall charger or a 15 kilowatts car charger. The drone is equipped with a parachute system capable of deploying even under full load, reducing fall speed to 6 meters per second in extreme situations. For navigation and obstacle detection, it uses a LiDAR system scanning up to 300,000 points per second, a millimeter wave radar for low visibility conditions, and a 5-direction fisheye optical system for spatial orientation. The DJI FC-100 is offered in 4 configurations. The standard version with regular charging is priced at $12,500. The flagship version is available at $16,000 for the standard charger and around $16,700 for the high-power charging option. Metro Naps Company developed the world's first energy pod, a purpose-built nap chair capsule designed for short power naps of about 20 minutes that help people restore energy and productivity without the need for full sleep in a bed, combining ergonomic design, technological features, and scientifically grounded relaxation methods, with a zero-gravity internal structure that slightly elevates the legs and maximally relaxes the spine to reduce strain on the cardiovascular system and back muscles, accompanied by specially composed music created in collaboration with sleep specialists to accelerate relaxation. And at the end of the session, the capsule gently wakes the user through a coordinated mix of light, sound, and vibration, so they awaken refreshed and alert rather than groggy. A humanoid robot began working at the Sany renewable energy production site, becoming one of the first examples of real-world deployment of human-like robotics in an industrial environment. The model is the UB-Tech Walker S2, which started performing tasks at a smart factory equipped with 5G infrastructure and a digital production management system. Unlike demonstration videos, here the robot operates in an active enterprise environment. Walker S2 performs sorting, transporting, and precise manipulation of parts, adjusting grip strength and body position depending on the object. Thanks to the built-in computer vision system, it recognizes items on the workbench, determines their orientation, and corrects its movement trajectory in real time. Integration with the 5G network allows the robot to exchange data with the production system without delays. This enables it not only to perform tasks autonomously, but also to receive updates, transmit telemetry, and operate within a unified digital ecosystem of the enterprise. Mojo released a video for Chinese New Year, showing its humanoid robot Mourin in an unexpected role, not as an assistant or industrial worker, but as a dancer performing a festive choreography in traditional style. In the clip, the robot appears in a bright New Year setting with red decorations and lanterns, moving in sync with the music, executing torso turns, smooth arm movements, and precise steps, demonstrating a high level of coordination and balance. The robot is human-sized, with proportions closely matching human anatomy. Mourin is equipped with a multi-joint actuator system that ensures fluid motion of the arms, legs, and neck. Special attention is given to the upper body. The robot's face is realistically designed with detailed expressions and features, making interaction more natural. The visual appearance is enhanced with a smooth skin and detailed body finishing, so the robot looks not like an industrial machine but as a next-generation social android. Lately, people increasingly forget the original purpose of humanoid robots. Not for flashy demonstrations, but for real work in environments initially designed for humans. This idea is embodied in the launch of the Atom U Ultra platform, a new generation of intelligent robots focused on practical application. Atom U Ultra is positioned as a step toward a robot out of the box, a system that does not require complex setup or lengthy configuration. At the core of the platform is a modern VLA model that integrates vision, command understanding, and action execution into a single architecture. This allows the robot to perceive visual information, interpret text or voice instructions, and immediately translate them into physical actions. In demonstrations, the humanoid confidently handles objects on a table, sorting, moving, and adjusting grip strength. Its movements are smooth, and manipulations are precise. The robot analyzes situations in real time and adjusts action trajectories accordingly. You are looking at a revolutionary development from Mojo Vision, the Mojo Lens smart contact lenses, which could become the most discreet yet most advanced wearable device of the next generation. Unlike AR glasses or headsets, these lenses sit directly on the surface of the eye and project digital information straight into the user's field of vision, creating the effect of an invisible interface without screens, smartphones, or bulky devices. The main feature of the Mojo lens is an ultra-high-density micro-LED display, about 14,000 pixels per inch, considered one of the smallest and sharpest displays in the world. It is so tiny it fits inside a soft contact lens, yet can render text, graphics, and augmented reality interfaces. The lens is also equipped with eye-tracking sensors, an accelerometer, a radio communication module, and an energy-efficient processor, allowing the interface to be controlled literally by the user's gaze without gestures or touches. At the same time, next-generation recovery capsules called Cocoon Wellness Pod were introduced by Wellness USA as a powerful system for deep recovery, relaxation, and wellness through a combination of thermal, vibrational, and light therapies, integrating modern wellness technologies to help reduce stress, improve circulation, accelerate recovery after exertion, and enhance overall well-being in short sessions. Using a dual thermal system with infrared radiation and dry convection heat that gently and deeply affects the body, relaxes muscles, and improves metabolism, with infrared heat penetrating deeper than traditional saunas to make the process more effective for blood circulation and natural detoxification, while built-in vibration massage, chromotherapy, and aromatherapy further enhance relaxation and help relieve emotional tension. Engineer and YouTuber James Bruton unveiled his new invention, the Sidewinder electric chopper, capable of moving not only forward, but also backward and sideways. The motorcycle is built on two omnidirectional wheels and is controlled with two controllers. This is the fifth Omnibike in Bruton's collection, all based on unusual self-balancing mechanics. The front wheel and fork are taken from one of his previous projects. It features a large drive wheel and belt-driven mini wheels that enable lateral movement. Instead of a traditional throttle, the bike uses a pair of controllers. One controls forward and backward motion, the other controls sideways sliding. In practice, the bike is not easy to handle. For example, turning requires leaning in the opposite direction. Meet probably the friendliest and most human-like robot named Yogi, a humanoid with a special focus on interaction, emotions, and assisting people in everyday life. This robot was developed by the American company Cartwheel Robotics, not just as a mechanical device, but as an emotionally and socially oriented companion robot. Its appearance and proportions are deliberately designed to be friendly and childlike. A rounded body, a large head, and soft shapes inspire trust and do not intimidate, even when Yogi is around children or elderly people. The robot is approximately 130 centimeters tall and weighs around 30 kilograms, compact enough to move comfortably around a home or office while remaining stable and balanced for daily interaction. Developers at PodTime have created innovative rest and sleep capsules, high-quality sleep pods that transform ordinary work or public interiors into spaces for effective recovery and productivity, providing a private and secluded environment where a person can relax, take a short daytime nap, or simply disconnect from external stimuli thanks to strong sound insulation and comfort. With PodTime sleep pods designed as enclosed mini capsules that enable full privacy even in busy offices, universities, medical facilities, airports, and other public locations, allowing people to take short breaks during the day that improve focus, memory, creative thinking, reduce stress, and boost energy without the need to go home or search for a quiet place. While the capsules stand out for their thoughtful design, spacious interior, easy assembly, and adaptability to different use cases.